What I want us to do is let's take a look at this warm-up. It's good practice from what we learned from 14.1. A little extra practice. So I got two quick examples for you. First one's the table. Second one is you should be able to look at a graph and identify what the intended height, what the limit is. Okay, so let's go ahead and plug these in real quick. So example 1, I want to find the limit of this function x minus 2 over x squared minus 4 as x approaches 2. So let's see if we can't find that. So I'm going to put, again, parentheses around that whole numerator, whole denominator. So take a second, guys. Get your calculators out. You can't learn through osmosis. You got to try this out. So I've got x minus 2 in parentheses divided by parentheses x squared minus 4. Big minus sign. So I've graphed it. I'm in Zoom 6. If you have any plots on, make sure you turn your plots off, and I should get this graph. Now, Raman, you might be getting like a connecting line here for some reason. Are you getting like a line there? Yeah. I don't know why yours is doing that. I'll have to look to see what, maybe you're in the classic vision version instead of the map print version. You know. We'll look at it after class. So you guys should get this graph. Anybody not getting this graph? Well, the first thing I always do is, if I got to find the limit, the first thing I like to do is, well, can I plug in 2? So second trace value 2, and I got nothing. So that tells me at 2, there's got to be a big hole there. And if there's a hole, there's definitely an intended height there that I can find. Okay? So I'm going to start plugging in these numbers. When I plug in these numbers from this table, I work outside in. So this is from the left towards the number 2. And then I'm going to punch in these numbers outside in. And those are the numbers from the right closer to 2. So I'm going to type in 1.75. So second trace value, 1.75. That gives me 0.266 repeating. Then I'm going to type in 1.9. That gives me 0.256. Then I'm going to do 1.99. That gives me 0.2506 and 1.999. And this time I got 0.2500. Well, if I look at that number and I round it, approximately where am I going? What is it getting closer and closer to? 0.2500 rounded is just what? Just 0.25 or about 1/4. Let's see if it's happening on the other side. So again, start outside in. Start at 2.25, which is kind of farther away from 2. That's at 0.235. Now I'm going to do 2.1. That's at 0.243. Again, getting closer and closer to 2. 2.01 is 0.249. 3 if you want to add another little decimal. And if I do 2.001, that puts me at 0.2499. Well, again, if I round that thing, guess what? It's going back to 0.25 or 1/4. There we go. These guys are the same. If those guys are the same, then that's my limit. The limit of this function as x approaches 2 is 0.25, or if they want a fraction, I would say that's about 1/4. Okay, the intended height, there's clearly a hole going on there because I can't plug in 2. Okay, if I plug in 2, I get an undefined value, but I can clearly tell from the left and from the right they're approaching the same height, the same y value, and that's my limit. Okay, you guys have any questions with that one? So remember this example because we're going to do this one algebraically today on the backside. We'll come back to see if we get the same answer. All right. All right, so one more review question. This time I've got the limit of this function. I've got cosine of pi x as x approaches 2. Okay, so as I take a look at my graph, here's 2. And from the left side, it's approaching this point. And from the right side, it's approaching this point. Well, it's approaching the same point, isn't it? And what's the intended height? What's my y value? 1. This is the coordinate point 2, 1. It's getting closer and closer to 1 as we approach that from the left and from the right. And if I plug in 2 now, if I do cosine of pi times 2, which is 2 pi, the cosine of 2 pi is 1. Okay, from our quadrantals, that's our 0, 1, 0 point. So it's perfect. So final answer for number 2 is 1. All right, do you guys have any questions from me? All right, so now, new stuff for today. That was review from 14.1. Now we're looking at 14.2. We're looking at algebra properties for finding limits. So we're going to use a little algebra techniques. Okay. And to be honest, guys, to find limits, I think using the table and looking at a graph is sometimes the worst way to find a limit. I'm an algebra guy. I would much rather do my factoring and simplifying and that kind of stuff to find that limit. I think it just makes it easier, and we'll see what we get here. So as we take a look, goal number 1, this says find the limit of a sum, a difference, a product, and a quotient. Goal number 2, we're going to look at the limit of a polynomial. Goal number 3, we're going to find the limit of a power or a root. And goal number 4, we'll probably have to talk about tomorrow or Thursday, find the limit of the average rate of change. Okay. We got some new rules here. So new rules for today. It says here, rules for limits. If I have the limit of 3, as x approaches any number, the answer is going to be 3. Understand that this 3 represents a function, like f of x equals 3. Or think of y equals 3. Okay? Visually, 1, 2, 3, we should know that this is a horizontal line. And no matter what x value you're approaching, the height of this line is always going to be 3. Okay? So basically, this is the limit of any constant function is the constant. The limit of 3 is 3. The limit of 5 is 5. The limit of negative 10 is negative 10. Because that's going to be a horizontal line, and the height of that thing will never, ever change. It will always stay the same. So that's the idea of that rule. You guys have any questions with that one? Remember, we're looking for y values, right? Heights. Next one. Says here the limit of x as x approaches c is c. And this one says the limit of x to the nth as x approaches c is c to the nth. Basically, what this is just doing is plug it in, little plug and chug. Whatever that x value is approaching, plug it in, and that is your limit. Okay? So, example 1, I've got a polynomial. I've got the limit of x squared minus 7x plus 10 as x approaches 2. Well, if I want to find the y value, the intended height at x equals 2, I just plug that number in. I'm going to get that coordinate point, right? So, plug it in. I got x squared minus 7x plus 10. Plug in that 2 value, this guy right here. Do a little simplifying. 2 squared is 4, negative 7 times 2 is negative 14 plus 10. And what do you guys get? What's 4 minus 14 plus 10? 0. Final answer. That's the coordinate point 2, 0. The height at 2 is 0. Okay, that's easy peasy. That's just the plug and chug idea. Same thing here with this limit. Example 2, I've got x squared plus 2 over x plus 2. I want to find the limit as x approaches negative 1. So I take a look. I've got x squared plus 2 over x plus 2. Plug in -1. Please excuse my dear Aunt Sally as we're doing this, Connor. So take -1 and square it. When I take -1 and square it, what do y'all get? We get 1, right? Anytime I square a negative, it's always positive. So I get 1 plus 2. And on the bottom, I get -1 plus 2. Well, that's 3. -1 plus 2 is 1, so final answer I should get is 3. Okay? So just do a little plugging and chugging, and it makes it pretty easy. Right? That's better than like making a table and all that stuff, right? Oh, man. So if you can, just plug in the number, it makes it super easy. Same idea with this last one for example 3. Example 3, I want to find the limit of this function. I got the square root of 6x plus 4 as x approaches 2. Well, just plug it in. I got 6x plus 4, and where the x is, I'm going to plug in 2. 6 times 2 we know is 12. 12 plus 4 is 16. What's the square root of 16, guys? Just how much? 4. Just 4. And guys, I always get the question, is it plus or minus 4? And the answer is no, it's just 4. Okay, you're not square rooting both sides of an equation where you need the absolute value or plus or minus. So it's just 4 is your answer. Okay? All right. So as we take a look at the next set, the issues that we have with 4, 5, 6, and 7 is that I can't just plug in 2 right now to the bottom. Okay? If I plug in 2 to the bottom here, I get 2 squared, which is 4. 4 minus 4 is 0. And then what happens when you divide by 0? It's undefined. You can't do it. Okay? So if you take any number and divide by 0, you get an error message. Okay? Well, that doesn't mean it doesn't have a limit. In fact, this is example number 1. We found earlier using the table method that we found that 1/4 was the intended height there. We saw that there was a hole there, right? So let's go ahead and do this algebraically. Now it says to find a function that has the same limit and agrees in all but one point. I'm going to explain that here in a second using the calculator. And then it says find the limit if it exists. So let's go ahead and do a little factoring. Teach me how to factor. Teach me how to factor. So let's factor this bottom here. You guys remember how to factor, right? Factors of x squared we know are x and x. What are factors of -4 that add up to 0 for this difference of squares? Factors of -4 that add up to 0. Shout them out. What do you guys get? +2, -2. Love it. And now, when we reduce here, remember binomials reduce binomials if they're exactly the same. We got these x minus 2's that are crossing out. Okay? Now I get this a lot where people say, well, the answer is x plus 2. I go, yeah, but no. You got to ask yourself, where is the x plus 2? On the bottom. So it's got to stay on the bottom. So if I get an x plus 2 on the bottom, leave it on the bottom by putting a 1 on top. Okay? Does that make sense? So this is the same function, reduced. Now we can find the limit of this function. Now we can take this 1 over x plus 2 and plug in 2. And it's not undefined anymore. Okay? So I simplify and I get 1/4. Okay? Now the reason why that works, let's look at this thing graphically. Okay? So at x minus 2 over x squared minus 4, that's where we started. Now, I'm going to type in this function right here, 1 divided by parentheses x plus 2. And close it. Okay? Those functions, as you look, the blue one was the first one, and now the red one is literally tracing over it. Right? The difference is right here at +2, On the blue one, there was a hole there. When we reduced it, we removed it, and now we've taken care of filling in that hole. So if I want to go second trace value now and I plug in 2, the blue one was undefined, but if I go down, now it's filled in. Okay, now I can find that limit. Okay, so these graphs look identical. Their limits are identical, just now I can plug that in and find it. Okay, well, algebra. So if it was my choice, I would do this, factor, reduce, plug in, as opposed to doing the table. I don't like doing the table. I don't know why. Yeah? So different process, finding the same answer. All right, let's take a look at example 5. I wish I could plug in -4 right now, but -4 plus 4 is 0. Doesn't mean there's not a limit there. I can still find the limit by a little factor reduce. So let's go ahead and factor the top here. What is factors of 12 that add up to 7? 4 and 3. And now we can karate chop the x plus 4. So now my function that looks identical except in one spot is x plus 3. Okay? This is a line, and this one up here is a line with a hole at -4. I filled that hole in now. Now I can plug in the limit as x approaches -4. So I can plug in -4 there, and -4 plus 3 we know is -1. Boom. Okay, questions, y'all? What do we got? Time for one more? You guys remember SOAP? Difference in sum of cubes. You guys remember this? For example 6, if I have something like this, x cubed minus 8, do we remember how to factor something like that? Let's go off to the side and remind ourselves. Again, if I have difference sum of cubes, I'm just going to take a basic a cubed minus b cubed here. Okay, it's been a while since we talked about this. I always use SOAP, and I think a lot of the Algebra 2 teachers use that. SOAP stands for same, opposite, always positive. When you have a binomial like this where it's a cubed minus or plus b cubed, it's always going to factor into a binomial and a trinomial. And there's going to be 3 symbols or 3 signs here. Same, opposite, always, positive. So same is referring to this guy. If that's a minus, then that's a minus. Opposite of minus is plus, and then always positive. Okay? Then I'm going to take my bases, a and b, and they go in the binomial, a and b. So I'd say my bases go right here in the binomial. On the trinomial, on the outside, are my bases squared, a squared and b squared. And then the 2 bases meet in the middle and multiply in the trinomial. So again, same, opposite, always positive. My bases go in the binomial. Bases squared. Bases meet in the middle and multiply in the trinomial. So bases, bases squared, bases meet in the middle and multiply. Okay, so there's your same, opposite, always positive. Do you remember that or no? It's been a while? I'm pretty sure I taught that to you. SOAP, you dirty dogs. You should remember your SOAP. Come on. All right, so SOAP, use your SOAP. I've got x cubed minus 8. So I'm going to write that as x cubed minus what cubed? What's 8 something cubed? 2. Okay, so let's move that over there. All right, leave that over x minus 2. All right, so I'm going to go ahead and factor this top. So I'm going to get a binomial and a trinomial. Same, opposite, always positive. Same sign. If that's a minus, that's a minus. Opposite of minus is plus. And then the last one is always positive. My bases are both x and 2. So x and 2 go there. And then on the outside of the trinomials are your bases squared. So x squared and 2 squared. Now I usually make that 4, but because we're doing notes and I want to make sure you got that, there we go. Then my two bases, x and 2 multiply. X times 2 is 2x. So bases squared, bases meet in the middle and multiply. And now that's all divided by this x minus 2. Now do you see why we can't plug in 2? Right? But karate chop. And now this leaves me with x squared plus 2x, and 2 squared is 4. Now I can find that limit as x approaches 2. I can plug in 2. I simplify, I'm going to write right underneath 2 squared is 4. 2 times 2 is 4, plus 4, 4 plus 4 plus 4 is 12. And that's it. All right, so ladies and gentlemen, we got number 7. We've got the limit of this function. I have x cubed minus 2x squared plus 4x minus 8 all over. X to the fourth minus 2x cubed plus x minus 2. Oh my gosh. Guess what happens when you plug in 2 to the bottom? Guess what you get? You get 0, and you can't divide by 0. Doesn't mean there's not a limit. Just means there's probably a hole there, and if there's a hole, we can find a limit. Well, when we have 4 terms, we learn something called factor by grouping. You guys remember factor by grouping? Where we group the first 2 terms together? So let me kind of cover this up, cover this guy up. Okay, I've got x cubed minus 2x squared. What can I take out of that? What do those 2 have in common?
X squared.
Yeah, buddy. I got an x squared, and now that leaves me with x minus 2. And now I group these 2. I take 4x minus 8, and what do these 2 have in common? Plus 4. And that leaves me with that x minus 2. Okay, I'm going to continue on. And the rule with factor by grouping is when you have these 2 quantities are the same, then these numbers in front can be written together as one quantity. So x squared plus 4 can be written together, and then you write x minus 2 one time. The reason why you can do that is because of how we do FOIL. FOIL means first and outer. So if I took this x squared and distributed it here and here, that's represented here. And if I take this term and I do my inners and lasts, well, that's represented here. So that's why we can take those x squared and that 4 and put it together as one quantity. Okay? Okay. All right, well, let's do the same thing on the bottom. I've got x to the fourth minus 2x squared. Let's go ahead and take out a what? X to the third. That leaves me with x minus 2. And then over here, I'm going to take out, I got x minus 2. The only thing I can take out is a plus 1. And that leaves me with an x minus 2. Again, because these 2 quantities are the same, the x cubed and the 1 can be written together. And then we have x minus 2 there. All right, I still can't plug in 2. If I plug in 2 on the bottom, oh man, it's undefined. But we have 2 binomials that are exactly the same. We can karate chop and reduce those. Okay, so what I'm left with now is my new function. I've got x squared plus 4 over x cubed plus 1. Are you guys okay with that? Any questions on my algebra that I just did? We learned that back in Algebra 1, believe it or not. Well, now I can find the limit. Now I can find the limit as x approaches 2. Before I couldn't, but now I can. So anywhere there's an x, I'm going to plug in 2. So I've got 2 squared plus 4. I have 2 cubed plus 1. And then I simplify. What's 2 squared? 4 plus 4 is 8. And 2 cubed, 2 times 2 times 2 Ocho. 8 plus 1 is 9, and I get 8/9. So again, that's called factor by grouping. Now, the kind of neat thing is we actually did this same problem yesterday in 14.1. So if you look at example 7, that equation, that function was the exact same one we did right here in example 5. We just did it a different way. We used our table, and we got the exact same thing. We got 0.8 repeating, which is, again, 8/9. Okay? So again, you're getting different ways to do these things. You have your table and looking at the graph and identifying what the intended height is. And you're also seeing your algebra techniques where we're looking to factor, reduce, and then we can plug in. Okay? Do you guys have any questions on 7? No questions on 7. We're okay. Yes? The 4?
Yeah.
What 4? This 4?
Yeah.
Right there? Oh, this 4?
Yeah.
These highlighted ones can be written together. So if these two quines are the same, we can write these two together. These two quines are the same, so the highlighted ones can be written together. And that's how FOIL works. If I was to take x squared times this, that's represented here, and then 4 times each one of those is represented here. That's why we can write them together in one quantity. Okay? Great question. All right, any questions on 7? All right, last thing, guys, we got to talk about the average rate of change from a function from c to x. Okay, so example 8, they're going to say, hey, find the limit as x approaches c of the average rate of change of a function from c to x. And you're like, what? What does that mean? Well, first thing is, understand what average rate of change is. Average rate of change. Have you guys heard of average rate of change before? Please tell me yes. What is average rate of change? What is the change in y over the change in x? We've learned that before. Starts with an S. Yeah. Slope. All right. You guys remember slope, right? All right. So we got slope. Remember slope, dude, right? What are you guys smiling about? I see your eyes smiling, Duncan. What's so funny? Oh my gosh, I did it again. I wrote slop. Oh, slope. Don't forget the E. Oh, man. All right, slope, not slop, Mr. Gotch. All right. Never gets old. Average rate of change is slope. Okay? You guys remember slope formula back in the day? Remember that? Picnic table, margarita glasses, unless you're James Bond, and then you have martini glasses, shaken, not stirred. And how old do you have to be to drink legally? 21. Unless you're drinking lemonade, and then you could be 12. It's y2 minus y1 all over x2 minus x1. Well, what they're trying to do here is, and this is going to be the big premise of where we're going in the next chapter. This is going to be basically the starting idea of what a derivative is, okay? An instantaneous rate of change on any function, all right? This is the kind of the start of that process. Well, we want to find, first off, the slope of this secant line. Okay, remember secant goes through a circle in 2 spots. Well, now this secant line's going through this function in 2 spots. Now they're using function notation. They're using c and f of c, and they're using x and f of x. Well, the idea is this is x1 and your y1, and this is your x2 and your y2. So basically they're doing y2 minus y1 is f of x minus f of c. And then they're doing x2 minus x1, which again is x minus c on the bottom. Okay, so hopefully that's a little clearer now. All right, and that's what this represents. Well, when they want us to find the limit as x approaches c, that's going to look like this. And this formula will be given to you guys. Again, you're going to have your notes. If this was non-corona time, I'd put this on the board for all of us to see, and then you would have to be able to use it, okay? So I want to find the limit as x approaches c of the average rate of change from x to c, or c to x, c to x. And that's going to look like this for my formula. So this is my formula that I'm going to be using. So I've got the limit as x approaches c of f of x minus f of c over x minus c. And again, this is going to be starting of the idea of what and how we find derivatives, okay, using the definition of the derivative. All right, so I'm going to write my formula here. I've got f of x minus f of c over x minus c. Now I'm going to start plugging in the things that I know. I want to find the limit as x approaches c. Well, the c that they gave me was 2. Okay? Then I want to do f of x. So let me use some different colors here. F of x is this guy, right? So I'm going to plug that in right there. That is x squared plus 3x. So far, so good. Minus, so minus sign, f of c. Well, f of c is something I've got to compute. So f of c is f of 2, which is take my function and plug it in, plug it in. And anywhere that I see 2, or anywhere I see x, I'm going to plug in 2. So again, simplify that. 2 squared is 4, 3 times 2 is 6, 4 plus 6 we know is 10. You guys okay with that? So I'm going to plug that in right here. So I've got f of x minus f of c. F of c is going to be a value. Okay, it's something that we're plugging in. And then on the bottom, x is x, and then minus, in our case, 2. I'm just plugging in c for 2. Okay, so again, I've got the limit as x approaches c. C is 2. F of x is our function. It's given to us. Minus f of c, f of 2, which is, again, 10. Make sure you subtract it because that's what the formula is. This represents y2 minus y1 all over x2 minus x1. In this case, c value, again, is 2. Well, I can't find that limit as x approaches 2 because if I plug it in, 2 minus 2 is 0, I can't divide by 0. However, doesn't mean there's not a limit there. There's not an, I can find the intended height if this is a hole. So I want to see if I can remove this x minus 2. And the way we do that is we factor. Teach me how to factor. Teach me how to factor. What are factors of negative 10 that add up to 3? Negative 2 and 5. X minus 2 is karate chop. And now I'm left with x plus 5. Now I can find the limit of this guy. Okay, these two graphs are exactly the same. This is a line, and this one is a line that has a hole at 2. Now I can plug it in and find out what or where that hole is. So we'll go ahead and plug in that 2, and we know 2 plus 5 is 7. So we know the intended height, the limit there, is 7. Okay? All right, all right. Do we have any questions there? No questions. Eventually, we're going to talk about what that means. And eventually, we're going to say, well, at that coordinate point, if we look at that slope, the slope of that guy at 2 is 7. So we'll see that, oh, yeah, that does kind of look like a tangent line that has a slope of 7. And that's kind of the goal eventually. Okay? Not quite there yet, but we will be. Where we start talking about that this is the slope of that graph at 7. All right, ladies and gentlemen, do you have any questions for me?